Hello guys, and welcome to episode number 57, where we'll be solving 5 more SQL problems, this time from Facebook right here. So let's get started with problem number 1. We have to find the number of posts which were reacted with a like. Reaction with a like is a filter. So we have to output one column and we have one filter. So let's get started here with our select from, and we have two tables. So let's see what we have. We have to output number of posts. We have to do a count of something, and this will be called number of posts. Number of posts reacted with a like, with a filter where, and we need here reaction. So we need to be working with the reactions table, and we're going to say where reaction equals, and let's see how they are writing it. They just write the word like. We're just going to copy paste it. And now number of posts would be simply this one, post ID. So we count number of posts, but we want to count the number of different posts because this table called reactions, there might be multiple reactions per post. So this should be the final solution. And there we go. The final number is 4. So quick recap here. We have to find the different number of posts where the reaction was like. Very simple. We actually have another table down here, the posts, but we actually don't even need it. Problem number 2. Which products had the highest sale? Products, highest sales. When we see something like this, we have to compare them based on the sales. And the sales are based on units sold. So not money, but units sold. That doesn't really make sense. We'll go with units sold instead of highest sales. And here we have to group them for each promotion. We have to output the promotion ID, the product ID, and the highest sales. So probably the units here. So we have 3 columns. And we have to rank them based on the number of units for each promotion. So let's get started here. Select from. We have only one table. So we need to show promotion ID. Then we need product ID. And lastly, we need the sum of the total units. We're going to go here, total units. And since we will be aggregating, we have to sum this one up and call it total units. Now to finish it up, we're going to say group by promotion ID. And then product ID. For every product in every promotion, we want to find the sum of units. Now we also want to rank these. We're going to use the rank function over, and here we want to do it for every promotion ID. So we're going to say partition by promotion ID, and then we want to order them by the sum of units sold in descending order, and we're going to rename this one to RNK. Now let's check out the result from what we wrote so far, and we have here promotion ID for every promotion and product ID. We are ranking them based on the units per promotion. Now all we have to do is put this in a CTE, and then we indent it very nicely here. Now we just select what we need: promotion ID, product ID, and the total units from CTE where RNK equals 1. And there you go, this is the final result. So quick recap here. In here, we just want to rank every product right here. Every product within every promotion ID. We want to rank them based on the sum of units in descending order. And down here, we just want to show the promotion ID, the product ID, and the total sales only where rank equals 1. Basically the number 1 product in each category. Problem number 3. You are given a list of Facebook friends and the list of the pages that users follow. So a list with friends and a list with pages that all users follow. Your task is to create a new recommendation system. For each user, find pages. So here, for each user, we have to find pages that this user does not follow, but at least one of their friends does. So the condition is, there's 2 conditions. User doesn't follow, and then at least one of their friends does. Then we have to output the user ID and the ID of the page with these 2 conditions, 2 columns and 2 conditions here. And down here we have the 2 lists. The list of friends. So this is the user ID, and these are the friends. And down here we have the pages, each user and which page they actually liked. So we actually want to show the user ID and then the pages that he didn't like, but their friends did. So clearly we need to create a list. Let's start it off with what we have to show up. We have to show the user ID and the page ID from the user friends, and we're going to rename this to A. We're going to inner join it with the user's pages, the user pages. We're going to call this B, and we will do it based on the friend ID equals to b.user ID. So here is a list of only our friends, the friends and the pages they liked. And we want to select the user IDs from this list. Now for every user, we want to say the page ID not found. And here we want to create a list of pages. So we're going to say page ID from the user's pages. And our condition is that the user ID equals with the user ID from our friends table. This one right here from the A table. We have to be more specific here with our first user ID because it gets confused with this one right here. We're going to name these the user ID from the friends table here and the page ID from the B table right here. Now it should work. And I forgot about duplicates. So we want to filter, we want to show only the unique users. And there we go. These would be the users, user 1, and these would be the 3 pages, user 3, these would be the pages, and so on. So quick recap here, we want to show all the users in the pages that they didn't like yet, but at least one of their friends did. So here is a list with their friends and the pages the friends liked. Now our filter is that the page of our user, it is not in this subquery right here, which represents the pages that he already liked. Problem number 4. In order to improve customer segmentation efforts for users interested in purchasing furniture could be a filter. You have been asked to find customers. We have to find customers who have purchased the same items of furniture. Purchase the same items, furniture. That would be the filter. We have to output product ID, brand name, unique customer IDs, and the count of unique IDs. And lastly, we want to arrange the output in descending order based on the highest count. I guess the count of unique IDs. We have to rank the products based on the amount of unique customers. So let's get started here. Select from, and apparently we have 2 tables here. So let's just write out what we need. We need product ID, brand name. This could be in either of them. Then we need brand name and the customer ID. Just gonna make a quick X here. So we need one from here, and the commonality here, the product ID. We're gonna have to join them using the product ID basically. And we'll take the first one, this one. We're gonna call it P from products. We're gonna inner join with online orders O. And we'll be using product ID since it's the same. And here we want to select product ID. Let's select it from the product one, product ID. And then we need a brand name from order. From, actually, this one is also from products. P.brand name. And lastly, we want to show O.customer ID. Right now, we can simply add our filter, furniture filter right here from the products right here under product class, where the product class equals with furniture. And now we further drill down on our results right here. Now we can simply add our count here. We want to count the customer ID, but we want to count it based on the product ID. So we're going to say partition by p.product ID. And here we'll name this number of customers. So let's check out the result. And this should be the result, just that we are having duplicated products here. So to remove that, we simply want to show the different products, the distinct product IDs. And right here, this should be the final answer. But we actually forgot to order by the number of customers in descending order. Okay guys, so since we are doing a count and we want it to be unique, we actually have to group by all 3 categories right here for every product ID and the brand within that and the customers within those 2. And this should be right here, the final solution. In problem number 5, last one for today, we have to find the date with the highest total energy consumption. That definitely means we have to rank these dates. the dates. We have to rank the dates from the data centers. Data centers. We have to output date along with total energy consumption across all the. What does that mean? Oh, I see what it means. We have 3 different tables and they have exactly the same columns. So you know what this means. This means we have to add them on top of each other. So we have to unite them. Let's actually start with that. We'll create this union as a different table. We're going to say, let's call this one energy totals as, and here we want to select the date and consumption from the first one. And we want to union it without duplicates because we want to keep the same dates with the second one, union with the third one. Now we just have to change here the Asia instead of EU and here NA instead of EU. So this is our table here. Let's just test it out. Select everything from energy totals. And there we go. These are all the dates from all of them. So we have to work with data from this one. So let's see what do we actually have to output. We have to output the date alongside with the consumption. That would be the sum of consumption, which would be total consumption for that day. And we have to group by date. And we'll use our energy totals right here. But this would be the result per day right here. But since we have to rank them, let's actually do that. Let's rank them. Rank over the order by the sum of consumption in descending order. We're gonna call this R and K. And right here we are only interested in rank 1, the date highest consumption. So in our case, since these two are tied, we need to show basically these 2 rows without this column right here. So we're going to transform this one into another CTE. Since we already have one, we can just say here comma, and let's just call this one CTE, and we'll paste it in here. So now we have 2 temporary tables. We have this one, energy totals, and the one called CTE. And now finally we can select the date and the total consumption from CTE where R and K equals 1. So basically we are selecting from the CTE table here, and this CTE table is selecting from the energy totals up here. And if we run this, there you go, we have our 2 days. So quick recap here. In this first table, we are simply combining data from 3 different tables, and we do not want to show duplicated dates. That's why here we didn't say union all, just said union. Here in the middle, we are ranking the dates based on the sum of consumption in descending order right here. Sum of consumption in descending order. And lastly here, we simply want to select the date, the consumption, where the rank equals 1. So that was it for today, guys. Thank you for watching, and if you enjoy these kinds of problems, I highly encourage you to join the StrataScratch community. Consider using the affiliate link in the description below. Thank you for watching, and I'll see you in the next one.